Hello students, in this video we will be discussing a numerical on the studied concept. See the next problem. It is on two-dimensional because input out the given, and here calculate all entropies. Anyhow, what are the properties? What is the entropies associated with the two-dimensional property? It will be h of x input side, h of y, h of xy, h of x by y by x. Those are the five. A discrete source transmit messages x1, x2, x3 with probabilities 0.3, 0.4 and 0.3. The source is connected to the channel given below. Calculate all the entropies. Calculate all the entropies. So first from the given channel itself, you can write the y by x matrix, the conditional probability matrix. What is y by x? y1 by x1, y2 by x1, y3 by x1. Next, y1 by x2, y2 by x2, y3 by x2. Next, y1 by x3, y2 by x3, follow. y3 by x3, 0.7. You can add all columns in that. Total should be equal to, all rows you can add. Total should be equal to 1. Once if you have the conditional probability matrix y by x, already input matrix we already know. What is the p of x? The given probabilities 0.3, 0.4, 0.3. Then how to calculate outputs? P of y equal to P of x into P of y by x. Then multiply these two you need to make. Then you can say 0.3 into 0.8, 0.24. Anyhow remaining will be 0. Next, 0.3 into 0.2. It will be 0.06. Then it will be 0.4. Then it will be 0.9. Are you following my point or not? So 0.6, 0.9, 1.5, 0.4, 5.5. Correct now? Here is the 6, here is the 0.4, here is the 9. 9 plus 6, 15. Yeah. So 5.5. Next, last column. These two will be 0, 0.3 into 0.7, 0.21. You can add all the probabilities in the output side also. It will be total is 1. Next, what we need to calculate? Once these two are done, y by x we got. Let's calculate the joint probability. What is the joint probability? xy is nothing but p of x diagonal. Diagonal means write the input probabilities in a diagonal form. Into P of y by x. What is the y by x? We just now got 0.8, 0.2, 0, 0, 1, 0, 0, 0.3, 0.7. Please do multiplication. This one. So 0.3 into 0.8. So 0.24. Next, this with this one. 0.06. Next, this one. How much you are getting? 0, na? This will be 0. Next also 0. That 0 means 0. Next, row take 0, 0, 0. 0, 0.3, 0. Next, this one with this column. This, 1 second. Yeah, that is this with these columns. Yeah, 0, 0, 0. Next, 0, 0, 0, 9. Next, 0, 0, 2. 1. Add all probabilities just for our confirmation. This is 3, 0.3, 0.6, 0.6 now. I add 0.3, 0.3, 0.6, and it's 0.9 only coming now. Just a second. It should be total probability should be 1. Somewhere we are missing. This is 0.24, correct. Remaining are 0. 0.06, remaining are 0. Here 0, correct. Second. This 0. Next this 0. This with this one 0, 0, 0. Done. Okay. Next 0. 0.3. 0. Okay, fine. 0, 0, 0, fine. Next 0, 0, 0, 9. Next 0, 0. Next obviously 2, 1. The input, oh sorry, somewhere we have missed. Yeah, they given 0.3, 0.4. Sorry, all I given as 0.3 written. Sorry, yeah. Now the small modifications will come. Anyhow, first one will never change. The second one, anyhow, this is 0. And the 0, 0, fine. Next 0, this is 0.4 only, a small mistake. And remaining as it is. Joint probability also we got. Next, get the another conditional probability P of x by y. How P of x by y will come is simply, these columns are divided by P of y. Columns are divided by P of y means this is divided with y1. This is divided with y2, this is divided with y3, you will get the answers. Then divide this one with y1. If you divide it with 0.24 by 0.24, 1, 0 anything will be 0, 0 anything will be 0. This column I will write. This is obviously 0, 0, 0.1, 0.1 is 1. And what is here, some different values will come. What is those values we will get is the students. Here 0.06 divided by 0.55, you will get a 0.109. This value is 0.727. This value is 0.164. Division, you can divide it by y2. Yes, once if you got the all, see, P of x have, P of y have, x by we have, y by x we have, and x by y we have. All these are the all probabilities associated with the two-dimensional. So now what is asking? Calculate the all entropies. Yeah. Let's starting with the first one. How to calculate h of x is nothing but minus of. So I written the probabilities in the numerator side. What is this value? 0.3 into log base 2 only. 0.3. Next one. 0.4 into log 0.4. 0.3 into log 0.3. Then calculate what is this value will come is. This is coming 1.571. Anyhow, units are bits per symbol. How to calculate the entropy of the output? H of y equal to minus of, what is this value? So see, 0.24 log 1 by, but I written the minus now. So 0.24, base is 2 only common. Next probability 0.55. So 0.55 into log 0.55 plus 0.21 into log 0.21. Then calculate how much will come. 1.441 anyhow bits per symbol. So 2 are completed. Third one, let's calculate. What is the entropy of xy? What's the formula? A common thing. That is summation minus of j equal to 1 to m. K is for output side. 1 to n. P of xj comma yk into log base obviously 2. P of xj comma yk. Write all possibilities. Here this is 3 by 3 matrix. So j 1 2 3. This is also 1 2 3. So total 9 combinations will come. But here in x by y only some of the elements are remaining. This is x1 y1. This is x1 y2 and remind this is 0. Anyhow, this is x1 y3. What is remaining you can write. Then what you will get? 0.24 log 0.24 minus of anyhow. Plus next remaining element 0.6 log 0.06 plus anyhow zeros, no need of writing. Next, this is x2 y2, so 0.4 log 0.4 plus 0.9 log 0.9, 0.21 log 0.21. Calculate for that one h by the conditional probability you will get as 2.053. 2.053. And how to calculate these things? You can apply the formulas. What is the formulas we are having for this one or maybe for this one? Minus summation j equal to 1 to m, k equal to 1 to n, p of xj comma yk into log x by y na, so xj by yk. Or here also in a similar manner you can write and write all the possibilities. Otherwise we already know relation h of xy equal to h of x plus h of y by x, or maybe h of y plus h of x by y. From here also you can calculate the both. And what is the values you will get for the entropy of x by y is h of x by y you will get as 0.612 bit per symbol, and y by x is 0.482. That is entropy, not the h of y by x. You will get as 0.48. These are the all possible entropies for a given channel. So from the channel, I calculated the channel matrix and given input already given, output calculated, and conditional and joint probability calculated. From there another conditional probability calculated. How I got this one? Dividing columns of joint probability by P of y. And then entropies we know the formula. Clear?